Okay, so thought it would help to have a video for molarity and dilution. There's lots of applications to stoichiometry, and you'll find that these are two concepts that we're actually going to use quite a bit. So what is molarity? Molarity is moles of solute over liters of solution. So it is a measurement of concentration, and what you'll find is everything we use in lab actually has a molarity associated with it. It tells us quite a bit. So if we have a larger number, it's going to be more concentrated. If we have a smaller number, it's going to be less concentrated. Now, molarity is temperature dependent. And you'll see here I have some particle diagrams to show what that looks like. So one thing you'll find is we're going to use this conversion that 1,000 milliliters equals a lot, because often in lab we'll be working in milliliters and not liters. Now, if you're given grams, you should be able to convert to moles pretty easily, and that's using the periodic table. So I have this guided practice problems for you. So all of these are going to end up at some point using this equation. So given 80 grams of NaOH, we're going to convert that to moles. So 1 mole NaOH is equal to 40 grams NaOH from the periodic table. So that's 2 moles. So my molarity is going to be equal to 2 moles divided by 2 liters, which is 1 m, or a 1 molar solution. That's how we would actually call it. Okay, the next question. Find the molarity of an HCl solution given 106.5 grams of HCl and 6 liters. So we take 106.5 grams HCl. We're going to convert that to moles using our conversion of the periodic table. I found that to be 2.9 moles of HCl. And then molarity is going to be equal to 2.9 divided by 6. So it's about 0.49 molar. Now the next one I find that people have a little more trouble with because they actually gave us the molarity. So just a reminder, molarity is moles over liters. So for this one I'm given 1.5 for my large M. And I know my liters is 250 mils, so I'm going to convert that to liters, which is 0.25 liters. So if I cross multiply, that allows me to find the number of moles. And you'll find that that is 1.5 times 0.25, 0.38 moles of this calcium chloride stuff. And then we know that 1 mole of calcium chloride is equal to 111 grams. So we're going to multiply that out. And so we find that to be 41.6 grams of CaCl2. Okay, the next part is dilution or neutralization. So we find that diluting a solution will reduce your number of moles of solute per unit volume, but the total number of solute in solution does not change. So MIVAI equals MFVF. We could also say M1V1 equals M2V2. Basically, if you know 2 molarities in one volume, you can solve for the other, or given 2 volumes in a molarity, you can solve for that other unknown. So here's kind of a visual what this looks like, and this works for both dilution and neutralization. Neutralization is a fancy way of saying an acid plus a base making salt and water. So let's see what that looks like. So we're going to use this equation, and so M1V1 equals M2V2. So I have 2 molar solution times 100 mils equals 1.2 times V2. So I found V2 to be 167 milliliters. Okay, so this one we can work in milliliters because as long as it's the same units on both sides. Okay, we're going to do the same idea on the next question here. So 2.5 is M1, 1.5 is V1, 0.5 is M2, and we're going to solve for V2. I found it to be 7.5 liters. And then the last one here, this is actually what I do when I make a solution for you in class. Or if you are, let's say, in a college class, sometimes you have to make your own solution. So we're going to take that 0.5 molar solution of 750 mils. That's what we desire. We have 12 molar back in that stock room. We're going to solve for V2. And V2 is equal to 31.25 milliliters of our concentrated acid. So if we're to make the solution, we'd use something called a volumetric flask. This would be a 750 milliliter one. We would put 31.25 mils of that strong acid inside, and then we would add water. Okay, and we're going to add water till it dilutes to that 750 mil mark. Now we could subtract 750 minus the 31.25 to give us a better idea of how much water we'd actually add. But you'll find with dilution and mixing, it actually changes the volume a little bit. So by using the volumetric flask, it's the most accurate way. Now, molarity and stoichiometry are related. So we can actually put molarity in as a bracket. So it'd be part of that stoichiometry process. So here I'm given the following reaction. How many grams of copper are required to react with 1.5 liters of 0.10 molar silver nitrate? So notice here, this is my volume given in the problem statement. And this bracket here, that is my 0.10 molar. Okay, I just wrote molarity in its parts. So that's 0.10 moles of AgNO3 per 1 liter. So then I'm going to take my 2 moles of AgNO3. That's going to go on the bottom. And then I'm going to go to 1 mole of copper. Again, this is from that chemical reaction. And then I'm going to convert my moles back to mass using the periodic table, multiply everything on the top, divide everything on the bottom. So you can see how this top-bottom units canceling can help us find other things. So that's like the most challenging I could give you. So there are a bunch of videos as well. I think the organic chemistry tutor videos are pretty good with this. Professor Dave, I think, is a little bit shorter one on molarity and dilution. And then there's lots of practice here that you can do as well. Sorry for the distractions.